Yes, I can. I'm ready to go and show you the virtual laboratory.
Okay, so I will stop sharing my screen and it's up to you.
So I can share my screen. So hopefully you have my screen here.
Yes, this is fine.
Is that okay? And I'll move this out the way as well. So what I'm going to talk about is I've only got 10 minutes, so I'll try and go through as quickly as possible. I know some of you already know about the virtual machine, so or about the method for the ESM, but I'll just go through very quickly on this. The first slide, what we have on that first slide is actually a product for Grand Paradiso, and thanks to Ruth who's on the call, and it sort of shows the type of data that we're getting, the type of maps we're getting. And the ESM system now does change as well as classification and also alerts, and we can develop that a lot more. So the ESM system basically takes a whole range of data layers from Earth observation data, and it will then extract information from those. It uses those biophysical layers, which are on the FTP site, a lot of them, and there's more can be added to create a land cover classification. So in a sense, there's no real training of, using training areas for doing the classification. It's entirely based on the biophysical variables. So the better those variables are retrieved, the better your classification, and similarly the better your change. So that's what happens. So we've been looking at a number of sites, and at the minute we have the virtual, all of these sites have been classified outside of the virtual laboratory, and a lot of them are now being classified inside as well. So we've got a few people using them, and we'd very much like others to use it as well. I'll explain how you can do that in a minute. The main basic idea is that we use the environmental layers as input to the FAO LCCS2, and we have a whole series of layers, and I will show you that on the FTP. But the main thing is that, for example, if we have semi-natural vegetation, it can be described by environmental variables such as the life form, the height, the leaf type, the leaf phenology, and the stratification, the number of layers. And so you can, each of those become separate layers as input to your classification. This is the way it works. So for example, we have in that part, we have woody, trees, shrubs, herbaceous forbs, graminoids, lichens and mosses in your life form strata, which is also down here. There's your life form. And then you can have cover as an environmental layer, and that cover can come from anywhere. It can come from Sentinel, it can be from a global layer that already exists, or you can do it from LiDAR if you want. The nice thing is it's independent of scale, this classification. The height can come from anywhere, or so the height's a different layer. Then you have the leaf type. You can use the European high resolution layers if you like, but it's good to try and update those. And phenology, and then also the layering of the canopy. So the key thing about it is that the LCSS has these codes. So A1 is woody, A3 is trees, A4 is shrubs. If you have information that's trees, then A3 overwrites A1. What you have to do is to effectively create a raster layer then, where anything you classify that, for example, anything that's woody is 1, anything that's trees is 3, anything that's shrubs is 4, and so on. And so canopy cover of open is 12, greater than 14 meters is 5, and so on. So they're separate layers, and I'll show you those in a minute. And what you do is you combine those layers. It simply searches through those layers, and it converts each of that. So that's A3, which is your trees, and A10, again, is the cover category up here. And so the code, it's just does this automatically, and it translates it to this description. So if you have information on LiDAR, you might find that you've got a second layer with an open canopy, 73 meters in height. If you don't have LiDAR, it simply becomes a trees, closed canopy, tall, continuous, broadleafed, and evergreen. So you can chop and change as you like. So here's an example. This is this is one layer called water. It could be water, ice, and snow. A1 is water, A2 is snow, A3 is ice, and then you have tidal, flowing, and so on. So you combine those as A1, B3, A4 and B6, which is tidal area flowing with a surface under the water of sand, sorry. So there's a whole range of layers that you can use as input. So you can get those from anywhere. So there's, for example, the lichen extent is from Norway, the leaf type is the high resolution layers, and the life form is a random forest classification of sentinel data, for example, or you could take it from LiDAR. You can do things like Ioannis in Surf, produce hydroperiods, then we can get phenology. You can use, it doesn't matter the resolution, really, snow cover you can use, and tree cover density and canopy height. So those are the layers that you use in the classification. What it does is they're continuous layers. You have something like a hydroperiod, which is continuous, canopy cover is continuous. And effectively, you can then convert those, or the code converts them to the LCSS classes. So you can now see that I've got this continuous surface of B1, 7, 8, and 9, and that's recoded as 1, 7, 8, and 9 in the layer that you put as input to your virtual laboratory. Then you have other layers which are not used in the classification. So these are all the environmental variables that are on the FTP site, or you can create new ones. And you can put anything you like into that. It doesn't matter. So what it does is you can put in vegetation, moisture, wind speed, which is not used for land cover classification, but it affects things like, you know, sand on the coast and so on. So that's the input. So you combine those and you get a classification like this. And what it then has as a legend, where you might have, for example, a needle-leaved open, dwarf, shrubland, thicket. And basically, it's exactly the same procedure as before. Okay, so what you can do in the virtual lab is you can create these for any area actually in the world. You can do this. So you just have to create the layers and then you run it through the virtual laboratory, and you'll be able to end up with the classification, which is has a standard taxonomy, and also their objects, and each object has all that information contained. So it's like an Excel table. Each object has all sorts of information, such as, you know, the above ground biomass, plant species, and so on. So let me just show you this on the FTP. So at the minute, these are all the data on the FTP, and if I go into any of these, so this is High Tatro, Kruger National Park, limestone, and so on. If I go into Doñana, as an example, the directory structure is set up so we have period 1, and I'll just do period 1 to start with, and you can see then that we have a classification in here, and this classification contains clump stock here, which is simply a segments with no data associated with them. So it's like a blank Excel file. You then go into thematic, and you'll see then you've got all these layers that we've just shown you. So it could be the water state, ice, water, or snow, the water movement, standing or flowing, the depth of the water, the phenology of vegetation, the life form, the leaf type, canopy cover, and so on. So all of those go in, and you'll distinguish between what is level 3. This is like an upper level classification in the hierarchy, which I'll show you in a minute. And then you've got the level 4, which is the more detailed layers that you need. So what you do is you can just take the FTP site in here, you can copy that, and this address here will go into the virtual lab. So I'll come back to that in a minute, so you can actually see if that's where your inputs. If you load your data up to the FTP, you can load up whatever you want. But the only condition is at the moment we prefer to have 10-meter resolution data, and ideally the same size of image. So, you know, 3,000 pixels by 3,000 rows for everything. Note there's a blank image, so if you don't have a canopy layer, for example, like or a life form layer, just put in blank and it will recognize that, and you get 0 values. So that's basically it, and you'll see then that they've actually got then period 2. There's another period in there, and that's got the same data layers, and they can be exactly the same. And period 2 can be a day apart, a week apart, a month apart, or whatever. And here we've got, you know, the upper level aquatic areas and water persistence, basically hydro period. So what we have here then is, and I'll go down to the bottom. Actually, I'll show you this one. So this is basically what we have. So if I just play this video for you. So this is the entrance of the virtual lab. We choose workflows. We then we have clumps, and we have our thematic layers, and our thematic layers the changes from period 2. So what I'm doing is I'm checking a previous run. So you have this previous run, which it has an ID. And this is what you get when you run the virtual lab, and you can see that in the black. And you can see now that this here is the path where the clumps are, and it's got an SFTP at the front. So you need to copy that across. Then you've got the period 1 and period 2 being highlighted there. And if you press run, you'll then end up with a WMS result, which at the moment is an image from here. And put into Google Satellite, you can zoom in, and you can then see the classification from Norway. But if you clicked on the object where it says clumps level 4 period 2 at the top, if you click on that, you'll basically get each object together with all the attribute information attached to it. We're shortly going to put it so you can download a shapefile and you can choose your attributes and color them up accordingly. If you want to go and choose another area, you can then copy in and put in another code, check the run. You can put in for this, in this case, it's Sierra Nevada in Spain. And again, you show the web map server in there. And you'll see then you've got Sierra Nevada in Spain. So it gives you a classification that, you know, is applicable to any site, and you mean protected area. People can compare their classifications between regions and so on. And you can download it. This shows you can download it. It takes, you know, 5 to 10 minutes to download, and then we can give you the software to view the Kia file as well. The Kia file is basically like an Excel file with information in it. So I will just click out of here a sec. Go from there. To go back up. Right, so that is the one thing it does. So we end up now, these are the classifications generated from the virtual laboratory. And what we then can do in this period 1 and period 2, we can start to look at the changes. So you can see here that this is cultivated, this is semi-natural terrestrial, but now this has become cultivated, and you see differences now between, you know, either urban areas, and they've moved into bare ground, and differences in water and so on. The level 3, it compares every single code. So it will compare for period 1, A1 woody might go to A2 herbaceous in period 2. So there's a color change there. This is an example then. So the hydro period is B1, 9 months, to B8, 4 to 6 months. So in your raster layer, B1 goes to 8 for the hydro period. So Doñana, we had a hydro period in period 1 and 1 in period 2. In that layer, 1 has gone to 8, and so it's highlighted as red. So it's basically red because it's a drying out. And here it's gone 8, it's gone to 1, and that's basically a wetting. So you can, and you also keep the continuous layers as well in there. What you can do, and this will be much more evident in the virtual laboratory in a few weeks' time, is that then you can color up all the changes. So what it does, it compares them, perennial greater than 9 months to perennial 6 to 4 months, and we'll design the virtual lab so you'll be able to then display each of these changes very easily. And this is the input biophysical layers which came from the FTP. So these layers are loaded from the FTP to the virtual lab. You literally press run. It'll give you this and tell you what's changed and so on. This is another example. So we can see that we can go shrubs to trees. So it goes from 14 to 10. You know, bare to trees is just basically it stays. There should have been a change in there. Oh, that's a different category. That's actually a different. It's non-vegetated to shrubs, and so on. So trees to shrubs. It then looks at other biophysical layers not used in the classification, such as biomass. It could be leaf area index, and it then accumulates evidence of why a change has happened. So if the evidence says it's regrowth, like it could be an increase in biomass, a change from trees to shrubs, or sorry, shrubs to trees, then you can say that's regrowth. And the more pieces of evidence you have, the more likely that you'll be able to, that is the change. So there's the capacity there for real-time change detection. And what we do is we work backwards, so you can have any type of change. You can just decide, I want to look at changes in water logging, and then you look at all the evidence that would tell you it's water logging. So it might be the hydro period increases, the water depth increases, there's aquatic vegetation, and so on. And the more piece of evidence that tells you what is it. And so you can split, but you can tell then, between degradation and selective logging. And it's color coded up as well, so you can then have color codes, as we showed before, of good things which are red, bad things are red and good things are green, and we can decide what's good and bad. So that's the key points. I won't read them out, just to sort of, I actually will do very quickly. You can do consistent classification of land covers for any site globally. In the virtual laboratory, you can include any biophysical layers, including time series within the classification, but also those that aren't used in the classification, such as biomass. You can include all sorts of different specific land cover, specific classifications, such as the extent of floating or rooted aquatic vegetation. It detects change in LCS codes and biophysical attributes, evidence-based approach to change detection. And you can also translate to habitats and other taxonomies, and was trying to look at how to do a cause and consequence. So there's a number of advantages. We do have a mobile app which can be used for validating it as well. That's probably a key thing. And so the validation procedures are being put in place. And it's all open source, the software, and it goes through GitHub linked to the virtual laboratory. So it will be improved all the time. And there will be the capacity very soon to give you access to code so you can develop your own evidence for change. Those are the codes, and that's the system, and I think that's it. Thank you very much.
Thank you very much, Richard. So now Mattia will follow up with a demo about the EODSM in GEOS.
Yeah, thank you, Yanis. And I'm going to share my screen. Can you see my screen?
Yes.
Okay,
yes.
So now Richard showed us, the EODSM, how it was ported in VLab, and how used to, compute the changes and so on.